Everyone, it's pajama day today here. I know you won't see us until next week, but just wanted to show you that even when you are not all here, we're celebrating homecoming week. Our teachers all dress up in our pajamas while you're probably in your pajamas, cozy in bed for this distance learning. Okay. So today we are starting a new chapter. As you know, yesterday we had a test. Hopefully that went well for everyone. Today we're starting something new, different, but something you've seen before. This chapter is on decimals and equations. So today we're going to be starting with rounding and estimating, another thing that I know you've probably done before. What you're going to see in this chapter is a lot of things that have similar ideas to this that are going to stem from using formulas that have to do with decimals, finding ways to make the problem simpler, things that we can do in our head. So today we're talking about rounding and estimating. Got out my trusty green pen here. It's more like a marker, but I'm not really sure. Anyway, we're going to jump into it. The first thing I like to get down is maybe just a little diagram like this, just in case you forget. So right now might be a good time to put this in your notes. You can also put these 1 and 2 in. There are little rules that I made. So what we have here is we have a number, 1.259. And all of these are different places. You've probably heard this before. Our ones place is right here. Our 1 is in the ones place. Our tenths, our hundredths, and our thousands. Tenths, hundredths, thousands. So we can round to each of them differently. So if they, for example, asked us to round to the nearest tenth, we'd round to a larger number than perhaps if they told us to round to the nearest 1. And you'll see plenty of examples of that, so if that's not making sense to you right now, that's okay. But basically, I gave you 2 rules here. When we're rounding decimals, the first thing to do is determine what decimal place you are rounding to. I should add a 2 there. Rounding to. After you figure out what decimal place you're rounding to, if the number before, see I popped in before there, before that number is 5 or greater, then you round up. If the number before is 4 or lower, then you round down. So for example, if I just said right up here 1.75 and said I wanted to round to the nearest tenths place. So we're looking at tenths place, that's 1 over from the decimal, rounding to the nearest tenths. So now what I do, if the number before, when I'm saying before, I mean this way, if that makes sense for you to say after, then on your definition you write after. But I have before. So if you want to write after here, if that makes more sense to you to think of this number, it's the one just to the right of it. So if the number before is 5 or greater, round up. If the number is 4 or lower, round down. Our number is 5, so we round up. And when we round up, we're rounding to the nearest tenth. So if we're rounding up, we're going from 1.75 to 1.8. From 1.75 to 1.8. 1.8 is the nearest tenth to 1.75 because when we get to 5, we round up. You're going to see a lot of examples. So we're just going to start cooking through these. I know this is something you've probably done before. Okay, so these ones over on this side asked us to round to the nearest tenth. I'm looking at my chart here. I see tenth is 1 decimal over. Tenths, hundredths, thousandths. So we're going to the tenth. I'm just going to underline these quickly so I know where we're rounding to. Perfect. All right, now we have to think, is the number before 5 or greater, then we round up. If the number before is 4 or lower, then we round down. Right here we have 4.2683. This number is what we're looking at. It is 5 or greater. It is bigger than 5, so this is going to round up to 4.3. You got it. 6 is going to help us round up. The closest thing to 4.2683, if we're rounding to the nearest tenth, it's 4.3. All right, looking at the next one, we have 7,098 and 56 hundredths. We're rounding the nearest tenth. I look at this number before. Again, it is a 6. I know I'm going to be rounding up. So I'm moving up to 7,089 and 6 tenths. Rounding that one bumps this guy up to 0.6. All right, looking at this one right here, we have 5.025. Here's my 10th place. This is the number that I'm looking at. Is it greater than or less than 5? It is less than 5. That means we're going to be rounding down. What this means is it's going to move from 5.025 to 5.0. Rounding down. This isn't going to bump up. It doesn't need to bump down, though, because it's already sitting a little bit above it. Moving on to the next. This one is asking to the nearest 1. Round to the nearest 1. That's our digit on the left side. That's right here, right here. All right, so I'm looking at the number before that. For both of these, I'm looking at the number before. I see 4.2683. Looking right here, is this greater than or less than 5? It is less than 5, so we're going to round down. And that's our final answer right there. If this had been a 4.765, we would have rounded up to 5. Here we are rounded down to the nearest 1. Round down, leaves us with 4. Next one, take a look at this. We have 0.7772. 7 is greater than 5, so we're going to round up. What does this 0 become? Rounding up here. Becomes a 1. We move this up, puts that 0 up to a 1. Those would be your answers for those two. And 2 more examples here. Round to the nearest. I already underlined it. It's different for each of them. We've got 274.9434. We're rounding to the nearest thousandth. So look at the number after that. Is it greater than or less than 5? It is less than 5. So my number is going to change like this. We're rounding down. We stay at a 3. Rounding down, we don't get bumped up because this is not more than 5. Looking at this last one, we have 83.41. We're looking at this number right here, figure out what we have to do there. It is less than 5 again, so it's going to become 38.4. Round down, round that down to the nearest 10th. Awesome job. I'm guessing that's a lot of a refresher, things you've seen before, things you've done before. Backside, we might have a little bit of new information here. So we're talking about estimating now. We were working on rounding. Estimating is a similar idea, but it doesn't necessarily need to go to an exact 10th or a 100th or a certain decimal place. It's more up for us to decide ourselves. So when estimating, I like to think, what good, easy number is close by? We kind of talked about this when we were doing our distributing, when we had things like 7 times 203. We read out that as 7 times 200 plus 3. This was us estimating a close number right there. We're going to be doing a similar thing with this. Right here I have one little definition for you. Not really a definition, more of a symbol. This is our symbol for approximately, or is approximately equal to. So just a little, basically a equal sign, and then they just gave it some squiggles. That is approximately equal to. So looking at our first one right here, we have 128 is approximately equal to. I'm going to think, what's a good close by number? People could have different answers here. One that I might like is 125. Another one could maybe be 130. Those would be both good estimating numbers. Both good round numbers are going to help us do some quick math in our head. When we're estimating, we're trying to make it so we have quick math that we can do in our head. Looking at the next one, we have 135.95. A few different numbers we could round this to, depending on how specific we're trying to get. Something that's more specific would be 135. Something a little less specific might be 150. It's pretty close to 150. Obviously, if we're trying to figure out how much money we owe someone, we're going to try to get closer to this number. But maybe if we're just roughly taking the head count of how many people are at a sporting game or something, it could be a little looser. So there's different options for these. Answers can vary. Looking at our next one here, we have 15.9. Great number to round that to would be 15. Or 20 wouldn't be so bad either. They're both good close by numbers. I think you're kind of getting the gist of it here. Looking at this last one, think about this one in your head for a second. What's a nice close number that would be easy to do math with? 25. 24.04. It's pretty close to 25. This is going to be some easy math for me. Right now, I am going to show you what our estimating does. We're going to use these first numbers I estimated. They're a little bit more specific. When I'm adding up money, I said it's better to be a little bit more specific. So for now, we're just going to cross those off lightly. And I'm going to be adding up these right here. So the first thing that I want to do is check the actual values. I'm going to see how much these were equal to. 135.95 plus 15.9 plus 24.05. And these total up to 175.9 before our estimating. Now after our estimating, let's see what these ones add up to. We got 135 plus 15 plus 25. 175. Look at that. We did some mental math and we were 90 cents off. This shows that power of estimating, how close you can get really with something just by taking some estimations. Right over here, I have something called cluster estimating. So we look at these numbers. They're all pretty close to something. What's a good number that they're all pretty close to? I see 1, 2, 3, 4, 5 of them. I look at them. Oh, they're all pretty close to 25. So I can do 25 plus 25 plus 25 plus 25 plus 25. Or if I see that they're all pretty close to 25, I can just count up how many there are. 1, 2, 3, 4, 5. And I can do 25 times 5. Real quick cluster estimation. 125 would be there. Let's see how close that would get us if we hadn't done the estimation there. I'm guessing pretty close because all of these numbers are fairly close to 25. This is called cluster estimation again. You see that everything in the cluster is pretty close to the same number. And 126.57. So yes, this cluster estimation worked really well for us. Another great method that you can use if you see that all the numbers are pretty close to each other. All right, we got a couple more practice problems here, and then we'll let you go. First one, estimate by rounding. They gave us two numbers here to add up. I see this one. I think, oh, that's pretty close to what? 355.302, pretty close to 350, I'd say. Plus 204.889, pretty close to 200. I get that together. These add up to, let's say, 550. Let's see what it actually would have been here. 355.302 plus 204.889. And they got, oh, did I mistype something there? Oh, I just did 24. I messed up. 204.889 plus. And they got 360.1. Pretty close to each other, once again, a good estimation. If I wanted to, I could have estimated even closer and said like 355 plus 205 and rounded these a little bit closer. That would have gotten me to 560. So just about how exact you want to be with those. Different problems are going to require a different amount of precision. All right, I got one more example for adding up money real quick. This is called front-end estimating. So what you do in front-end estimating is you split up to the fronts and the backs. I'm going to move my backs over here into an estimation. So when I estimate them, I just want a number that they're pretty close to. Right here, I see 71 is close to 0.7. This one, again, is close to 0.7. This one is close to 0.1. So I estimate those back sides. What I'm going to do with the front side here is I'm just going to add them up. 2 plus 1 plus 1 is 4. Now I go into my estimations. Let's see what I have here. 0, 7, 7, 1. That gives me 15. Now I take this number right here, which is just those, plus that, and get 550 as an estimation there. I take those front numbers, add them up quick, take the back numbers, estimate them, add them up quick, get 550. It's going to be a pretty good estimation. Another strategy, I'll practice one more right here. Start with the front. We've got 6 plus 2 is 8 plus 9 is 17. So at $17. Take those back sides. I like right here, I'm going to estimate this as 0.75. I'm going to leave it like that. To make my math a little easier, I'm going to turn this into a 0.25. I'm going to round that up to a 0.25. There's me estimating again because I know that these are going to add up real nicely. And I already saw that this is a little bit more than 0.5, but I'm going to round it down, try to make up for that a little bit. Add those up real quick. We got 0, carry a 1, 8, 9, 10, 15, 150 again for change. Add those two together, we get 1850. Let's check our work real quick. 6.75 plus 2.2 plus 9.5. 1853. So real close again. These estimating methods are working out for us. Again, there's a lot of different answers for estimating. When we're rounding to a specific decimal, there's one exact answer. These are methods that you've all probably seen before and are a little bit familiar with, so I hope this lesson isn't too tough for you. You can get started on that homework. Good work today.